Hello, everybody, and welcome to the next session at the Layer 123 Europe 360-degree Network Automation Congress. I'm very happy to be joined here by Alla Goldner, the Director of Technology, Strategy and Standardization at Amdocs. And her presentation is entitled End-to-End Network Slicing Automation, Foundation for 5G Network Services, Monetization and Optimization. Welcome, Alla.
Thank you very much, Milad, and it's really a pleasure and honor to speak here this Congress. So I'm going to talk, as Milad had mentioned, about network slicing and specifically more about aspects which are, the larger audience less aware about, which are monetization and optimizations in the network based on network slicing functionality. So first of all, a few words about, 5G standalone and the timelines of 5G deployments and what is associated with 5G deployment and 5G standalone deployment. So, we are now in beginning of 2021 and, some announcements, some deployments were done already for non-standalone, and we already start also deployments and an announcement about the standalone deployment, where basically we have both new radio and a new 5G core function. Now, which is not only that new radio and new core function, but the whole network design, which is changing and associated with that move. Partially because of the time frame, partially because indeed of those standards which change. So those things which come along with the standalone cloud-based deployment, cloud-native functions, which radio and core and some of the transport pieces compose of distributed network, also related to the edge deployments, which happen where basically you pick up location in a way that satisfy the service requirements, for instance, the low latency requirements of the service. Slicing ecosystem where basically you can run several virtual network, which we call slices over the same network, and so on. So basically, within this year, next year, we are going to see start of standalone deployment. And as I said, slicing is the key part of it. Slicing is associated with standalone, 5G standalone deployment. You can really deploy it when you have 5G RAN and 5G core. When the next years, starting from 2022, that same deployment, but will be implemented at scale. We will see more and more service providers actually moving to that deployment and as a matter of fact, deploying network slicing along this way. And now what indeed, are core characteristics of such a network, which is an architecture topology, which used to be centralized and monolithic. It's moving to become distributed and modular, disaggregated, again, in order to satisfy those requirements to support a different data centers by public, by cloud providers, service and resource model, moving from hardwired and fixed network into the network which is supported by the use cases and resource elasticity. It is a user application experience, used to be best effort for all, except for some very limited, application provided by the service providers such as Volte, with a guaranteed quality of experience, tailoring the service across RAN, transport, and core by the technology such slicing. For instance, it is RAN moving from the physical BBU deployed in proximity of antenna to virtualized, containerized, and disaggregated RAN, with RU, CU, DU, communicated by standardized interfaces with radio intelligent controller. Those are supported by Autom. Core used to be centralized, supported by the physical network functions. Some virtual network functions moving largely into cloud-native network functions with a lot of distribution along the different data center, and transport from unified backhaul transport with static configuration to mesh and composite backhaul with dynamic configuration using SDN. Now, all these changes, of course, require network management system, which, can support those because, distribution is fine, disaggregation is fine, cloud nativeness is great, but all this would work and, quality of experience would be assured when we have a a system, a network management system, which can design those services, unifying service design and orchestration for services which are enabled by stitching together all those pieces and forming network or forming slicing in a dynamic manner, federated inventory to have a comprehensive view of the many more moving pieces at the network now. As I said, that's all thing of distribution, having many pieces in run side, many pieces core side, fine, but moving also required a tools to monitor that, and here inventory comes, and of course on assurance side, advanced assurance to proactively recognize and automatically address service impact of issue in such a complicated network. And here Amdocs comes with its experience in building the network management system recognized in BSS and OSS parts, in actually providing NEO solution, which is Amdocs service and network automation of having open network designer, or the end service orchestrator, open network orchestration, activation tool, and of course inventory to monitor all the activities and present a real-time view of all of the network resources and network function status in the network. So that's the whole solution that we believe must be there in the network in order to support such a complexity that network brings, and also, bring up the opportunities that slicing brings. Okay, you would run a multiple virtual network over the same network, but provided by, quality of experience with the assurance system, lifecycle management of all those network functions, and inventory again with that real system view. So this is the solution that we are providing. And of course, in such a solution, the slice manager that I briefly touched is a key part of that solution. And when I say slice manager, it is one of the use cases that NEO or the whole network management system supports. But to be honest, this is the key use cases as we talk about 5G, because that support really, that need in an automation and assurance of the service across RAN, transport, and core. So you are not longer satisfied with the domain level RAN or transport or core network management only. You really have tools here to life cycle manage the service across the different domains and also assure the quality of such a service. That's on one side. And on the other side, that's on vertical side of connecting the different domains and assuring the service running across the different domains. On the vertical layer, it's connecting the BSS system, starting from ordering of the service through OSS layers deeper into the stack associated with network management. So, really we can see the full chain starting from ordering towards the assurance of the slices. So again, as I said, both vertical and both horizontal integration of the component create our solution for the slicing manager. Now, a few words really on design, different components of the solutions, design, orchestration, and operations. So within the design components, there is an onboarding happening, service components and resource modeling, slices and services design. All the resources are being instantiated and tested by the orchestrator. Now, for instantiation level, basically, as I said, through the order management system, what is happening is that, the request for the service is received but service is, service is associated with its name, not with its network parameter, like, for instance, gaming service. Now, it is the role of the slice manager to translate that name, that acronym of the service into network parameters, decompose relevant end-to-end network slice template, retrieve configuration and placement data, look for available active resources, network functions, and eventually run network slice instantiation workflow, and basically establish slice across RAN, transport, and core, while some of the slice resources may be dedicated and some of the slice resources may be shared, for instance, network functions which are shared across different slices, while some other may be only dedicated to that particular slice. For example, in case, again, low latency or bandwidth hungry application, then, UPF of the core network can be put close to the user. So, those requirements are satisfied. Eventually, after the slice is established, also charging and billing for that new slice is initiated, and I'm going to talk about it shortly. Additional part of the slice management is operation, as of course, when you basically establish the slice, you have to make sure that it is assured, the quality of experience is assured across RAN, transport, and core, and for that, the assurance, the operation system is being applied. In case there is a performance breach notification, the system provides a sign to the corresponding network functions, or even to scale or to heal, or even, instantiate a new network function, and that happens in the closed loop without intervention by the human. So that actually something that system is handling. Now, the solution that I explained in brief, strongly supported by standards. So, 3GPP defines network slicing, defines slicing templates for RAN, for core, defines how those layered architecture of slicing should be working. NFV defines the orchestration of network slices, and then FVO component associated to that. CMEC defines all aspects related to the mobile edge computing, while ZSM is basically defines the architecture for the end-to-end slice management across RAN, transport, and core, and assurance for such system. Also, GSMA, MEF, and SO are involved to define some certain aspects. On the open source front, I would mention, mostly ONAP and ORAN. Deeply engaged in slicing. ONAP strongly support network slicing use case, and we as Amdocs are key members of the group leading network slicing use cases and contributed design of the slices. And basically in ONAP there is already an implementation as well of RAN, transport, and core slicing, and even communicated with external vendors network management system, not only based on ONAP. So all this is being already supported. ORAN side is actually taking care of ORAN slicing and how that ORAN slicing would be a part of the overall end-to-end slicing picture in case of existence of non-real-time RIG, near real-time RIG, and all O1 interfaces in place. Of course, this is still in the beginning in a way of, it is not product ready development, but there is a lot of development right now, and as we move forward, there will be also products based on that. And as I said, we in Amdocs, we are leading work in ONAP, also in ORAN, we are closely monitoring that, and as soon as that part of ORAN integration into overall network management picture and network slicing picture becomes mature, we will also adopt it as a part of our product. And now a few words about charging. And as you know, in mobile network, basically SMF, session management function of the core network, is the network function responsible for providing the charging reports on a mobile session base for subscribers. So subscribers are being charged. Now, obviously, that method is good for the consumer market. But for enterprise market, where basically, you care perhaps less about how much each one of the enterprise employees uses of certain application, but you care more about basically two things: resource consumption of the resource of the data centers, which are being leveraged for slicing, and performance of the slices, quality of experience of the services running over the slices. So 3GPP in release 16, which is an advanced release of 5G. Release 15 is the first release of 5G and 3GPP, actually approved conclusions of the study where orchestration system and basically part of the slicing support, NSMF, network slice management function, becomes a charge and trigger function. So the orchestration, the NSMF reports to the charging function on consumption of the slices in terms of resources, memory, CPU, storage, as well as performance of the slices for the services running over those slices. And, we in Amdocs strongly believe in that method, firstly, because, 5G is largely about enterprise and enterprise monetization. And this is really something which provides the tools for such and monetization. And secondly, because, us being a BSS and OSS vendor and actually that NEO vendor, the whole network management platform, we really see us as, the expert in providing that full solution, connecting the BSS layer of charging, of monetization with the layer of the orchestration. So this is the solution that we are building, our slicing management becoming the charging trigger functions and reporting basically to the charging function on the consumption of the slices. So that's what we call monetization package. Here on the picture, you can see it. Basically, as I said, network slice manager becoming charging trigger functions, open it, which is providing a charging functions, gets the information and further into those charging and billing mechanism, eventually charges enterprises by slice consumption and performance. One additional cool thing I wanted to talk about is NWDAF and how it relates to network slicing. So, I basically believe that NWDAF is one of the largest things which happened to 5G if we talk about innovation, because this is something which was not existing before 5G. NWDAF is network data and analytic function, part of the core network, which basically gets all of the reports from network functions, from repository, from network management system, meaning orchestration system, works on those reports, builds statistics and predictions out of those reports, and provides that outcome information to any possible consumer in the network, which also can be network management system, network function, network repository. So this is NWDAF. NWDAF was actually defined back in release 15 already, but was largely extended in release 16. And in release 17 now, really, many use cases are being defined. Now, we just open it, are building a joint solution inside of Amdocs, where actually NEO with the capabilities of design, orchestration, inventory, and assurance is combined with open and charging and policy and network exposure functional to build the system NWDAF. And then I said that it is basically about combine the set of the information that we have on the network management layer, the measurements that we received on network statuses, on network function consumption, and from the other side, the information available on OpenNet side or in terms of subscriber, how much subscriber consumed, where subscribers are now, geographical location, where subscribers are heading. So, those two sets of information were not available. It was not possible before 5G to actually to combine and bring up, consolidated view on the network from network and subscriber perspective and build consolidated solution based on that. But this is what is possible with 5G, and this is what we do. And so I'm going to briefly touch 2-3 examples of what can be done here. And of course, there are many more. And of course, there is, you can ask me any question also, under Q&A or personally, I would be happy to cover, but let me just bring 2 examples. So one example would be what we call network function forming and placement. And basically the idea is that, policy by providing us with the information on subscriber location, subscriber consumption may help us, the network management system, through NWDAF, to decide where to instantiate network functions, where to scale network functions, how to scale network functions. Example is subscribers are heading towards some stadium. So in advance, policy would let us know. So we in advance would scale up the resources at that data center. So this is something which started to be possible with the introduction of that NWDAF mechanism, combining our network management capabilities and combining policy and charging knowledge. And one other example in the opposite direction is that we know the network consumption, we know the network costs at each of the location. We can provide an information through NWDAF to policy, and based on that policy may redirect mobile session to certain, network functions in the network, and may even limit the bandwidth of certain mobile session of the subscribers, for instance, who pay less. So this is another example of how we, with the information on the network management layer, on the network layer, can feed up policy and charging so they can be more efficiently. And this suite of products we call optimization. And to summarize what I said, so network slicing is indeed bringing a lot of opportunities to monetize, to optimize the network, not just the network management layer which is a building, but actually reporting to charging system on the consumption of the slice, on the services, on quality of experience of services running of those slices. On the other side, for optimization, it is provide an opportunity of actually optimize the full view of the network. One from subscriber side, the second thing from network management side and network function consumption side, and those sets of information combined together can bring to a much better optimization of the network. Indeed, there are standards who are in process of defining it and developing it right now. And we in Amdocs, as the company who strongly participate and lead in those standards activity, also innovate in our product for those related functionalities. Thank you very much.
Thank you, Alla. I'm just wary that we've gone a little bit over, but I think we can take one or two quick questions. Romualdez from Telia company in Lithuania asks, which ready access technology might be supported by this end-to-end solution by Amdocs?
So access technology, as I said, 5G standalone support is a must. If you want to implement slicing, with monetization, optimization by standardized methods, so you must have 5G NEO ready and 5G core. So that's the basic. If you have those, then you can have this implemented. Of course, that would require building of charge and trigger function inside of the network slicing manager and appropriate support by your charging system.
And the last one from Lin from ZTE in China asks, has Amdocs achieved any IoT with third party for end-to-end slice?
Yes, of course. We support with our slicing manager, we support many use cases, and of course, some of the key use cases are IoT related, with smart city, with the health industry, IoT is key part of it. So, we are building those slices dedicated for different IoT services as a part of our network slicing management operation.
Thank you, Alla. Okay, one quick last one. When would you expect NWDAF to provide input to RAN-SON or non-RT RIC for optimization?
Sorry, I didn't understand the last part.
Non-RT RIC for optimization.
So when? Well, that's an interesting question. Well, I would say that the key functionality is defined in release 17. As I said, release 15 was actually the declaration of NWDAF presence. Release 16 was standardization of several use cases. Release 17 consists the most of the use cases, which is going to be supported in 5G. So I would say standard fully will be available most likely next year, right? So I would expect the first implementation associated to that, perhaps, end of the next year, end of 2022, beginning of 2023. But, as it usually happens, there are POCs, there are trials, and we are being requested quite a lot about this functionality. As I said, we are leading and innovating in that. So, definitely looking forward to take those trials and POCs into real network implementations.
Thank you very much, Alla. Alla's video will be on demand throughout today and the rest of the event. So please, if you've got any questions, either put them in the chat box or if you send them through to us, we'll be sure to pass this on to Alla. Thank you very much, Alla.
Thank you. My pleasure. Thank you.